Hi, my name is Ryan David. This is my entry into the 2010 Parallax Propeller contest. It is an automotive data acquisition unit called the DAQPac. Here we have the DAQPac powered over the debug port. It has power, ground, and all communication lines brought to a 2x5 header. At the heart of the board you have the Parallax Propeller. Beside it you have the USB communication and wireless transceiver. The USB and wireless transceiver share communication lines, so that way any data available over USB is also available over wireless. In between the wireless and USB interfaces, you have the power supply. A switching regulator was selected for its wide input ranges and efficient operation. A voltage divider feeds back the ignition line into the one-channel ADD. This will allow the module to verify the integrity of the power supply and make sure that the ADD reference voltage stays consistent. 18 analog inputs, 2 TAC inputs, 3 control lines all go through the main module connector. All the analog inputs have transient protection and a low-pass filter before they are fed into the ADDs. The ADDs are 10-bit 8-channel ADDs from microchip. The ADDs share a common chip select, data in, and clock signal, and each have their own data out pin. This allows the propeller to request the ADD conversion and get the results of 3 channels simultaneously. Beside the ADD is a 3-axis 2G accelerometer and a 150 degree per second gyro. Upon module startup, the micro toggles a self-test pin connected to both devices to verify integrity and bias. Next are the thermocouples. There are 2 connectors for Type K thermocouples, and they are read using a maximum thermocouple ADD. Just like the main ADDs, they have their chip select and clock pins tied together and their own data out pins. The cog driving the thermocouple sampling is also responsible to keep track of the tachometer inputs. By using the cog's 2 counters and negative edge mode, the precise tach signal frequency can be captured in the background of other tasks. Positioning is done by a SkyTrack GPS receiver. This receiver features a high sensitivity and 10 Hz position update rate. To read the GPS sentences, a hybrid serial communication and NMEA parser was created to run in a single cog. Finally, there is a SD card socket. All the data is collected by each cog and stored in the hub. The SD card driver grabs the data from the hub and writes it to the card. A NOR gate connected to the card detect and write protect pins with pulse resistors lets the propeller know when a card is inserted and writable.